we're going to have a discussion on question that you may be asked, and also I may give you tips on how to approach different areas that we may be tested, as we are going to be meeting different questions in this paper. So in this paper of May-June 2024, candidates were given a scenario whereby they were told to calculate the mass of the object. And then you can see here what we have on our end is that, let me just move this a little bit so that I can be able to write. You can be able to see from your end. So candidates were given the mass, and then the mass was suspended on the mass was suspended on the rod, and then we are told the force due to the load was given as 0.75 newtons. So if you look at that, basically the question is asking us to use the formula weight is equals to mass times gravity. And you have always to come and check and see what value of gravity is provided here, so that you can be able to be able to use it. And you can see now that's exactly what I did in this case, so that I can be able to say weight, which is equals, because this object is suspended, and is suspended here, so which means that the weight and the tension force, remember the tension force will be acting upward and the weight of the object will be acting down. When this object is at equilibrium or is balanced, it means the two forces are balanced. So if you know the tension, then it means you know the weight, and our weight now is going to be equal to the tension. And if you're going to work out for the mass, you're going to get your final answer being 0.07. I think I need to erase this. I write it properly. This is going to be 0.077 kilograms as the mass of this particular object. The next question that was asked is to work out the resultant force, because we were told a force was exerted somewhere here, and that force is the one that I've indicated on this diagram. So meaning that we're going to have two perpendicular forces, one force that is acting in that direction, which is 1.2, and the other force that is acting upward, which is 0.75. Then now for you to find the resultant force, which will be this force that we have here, it means we are going to use Pythagoras theorem, 12 squared plus 0.575 squared, and that is going to give us the exact force that we were supposed to work at this particular point. So meaning, using Pythagoras theorem, you're going to get our final force being equals to 1.4 newtons as our resultant force. But also you remember, you are told we are also supposed to find the direction of the resultant force. We're supposed to find the direction of the resultant force relative to the vertical direction. So in order for us to find the direction of the resultant force, we are going to work out this angle that we have at this point. We are going to work out this angle that we are having here. So for you to work out that angle, you can be able to use you can find theta, and then you subtract from 90, because I found this angle in the first place, theta. Then the theta I'm talking about is this theta. I worked out this theta, and then I went ahead to subtract that theta, which is 32. I subtracted from 90 to get actually 58 degrees, which is the required angle. But another way you could have done this is using this as opposite and using 0.75 as adjacent. Then you apply tan of 1.2 over adjacent, which is 0.75, and that is going to give you the direct answer, because in that case we'll have the angle that we need. This angle that we shall have here will be equals to tan inverse of opposite, which is 1.2 over adjacent, which is 0.75. And if you work it out, you are going to get it 58 or 59 degrees direct. So it's you to decide which is the best method you can be able to use at this particular point. Moving further to other question that you were asked. Forces produced changes the size and the shape of the object. Then now here candidate was supposed to state which other what are other effects of force. What are other effects of force you can be able to state. Now in this case we're going to say force can change the speed of the object, or it can change the velocity of the object. It can speed up or slow down an object. And then we can also say force can be able to change the direction of the object. Moving further to this, we are also given a question to define. You may be asked to define the term acceleration. Acceleration is the rate of change of velocity, or we can be able to say is the change of velocity per unit time. Change in velocity per unit time. So different ways you can be able to define acceleration is rate of change of velocity or change in velocity per unit time. You can also be asked to define deceleration. You're going to say that the rate at which velocity is decreasing is the rate at which velocity decreasing, or you can say also deceleration is negative acceleration, and still you have your marks there. Calculate the time taken for the train to reach this particular speed from 15 to 28 if it's accelerating at 1.1 meters per second square. So the first thing we need to understand is that acceleration is equals to change in velocity over time. But how do you get change in velocity? Is final velocity minus initial velocity. Our final velocity is this one here. This is V final. And this one is the initial velocity. So you are supposed to subtract the two. And then you say 11 is equals to 28 minus 15 over the time which we are trying to find. And if you work it out, you're going to get your answer being equivalent to 12 seconds. That's one of the value you're going to find. And also you may be asked to work out question to do with force, mass, and acceleration. So the equation that connects force, mass, and acceleration is this one. And in this case, you need to check acceleration was provided, and then up here we were having the mass. So which means you can be able to find the force by multiplying the mass and the acceleration, and our force is going to translate to this particular value that we have at that point. And that is it. Explain why the force on the train due to the motor it should be greater, because the motor, the one that I usually run the train, and we are supposed now to explain why the force due to the motor is greater than the value that is calculated. We need to remember that always there is what we call friction, and there is air resistance. And all these, they try to resist motion. So it will mean that more work has to be done, more force has to be supplied so that we can be able to do the same amount of work. So additional forces, in this case, Candice was supposed to say additional force is needed to overcome air resistance and frictional force. So that's exactly what Candice was supposed to state there. In question number 3, it was about conversion of conversion of energy from one form to another. And in this scenario, a student drops a heavy ball from a vertical height of 1.8, and then we're supposed to and it hits the ground without bouncing. So meaning that all the energy that the ball was having will be converted to another form. All right, so which means that we're supposed to describe the transfer of energy of the ball between different stores where the ball begins to fall when it reaches to the ground. So the first thing that candidates were supposed to understand or realize in this particular question is the fact that candidates were to remember that energy transferred, conversion of energy, is basically the law of conservation of energy, and that means that when the object is at that particular height of 1.8 meters, it means that that object is having gravitational potential energy. The moment that object starts falling down, or the potential energy will be converted to kinetic energy. So in the process of falling down, gravitational potential energy will start decreasing, but kinetic energy will be increasing. By the time it hits the ground, it will mean that now the gravitational potential energy will be, all of it will be converted to kinetic energy. And in the process, all that kinetic energy will be converted to thermal energy. So you are supposed to highlight 3 points. At the top above the ground, it has potential energy. As it falls, gravitational potential energy decreases as kinetic energy increases. When it hits the floor, all the kinetic energy will be converted to thermal energy. And also there is another concept that was introduced here to calculate the maximum speed. So remember, gravitational potential energy is the one that is basically converted to kinetic energy. And in that case, you needed to remember and write the formula for gravitational potential energy is mgh, but you can see mass will cancel out. You remain with g h is equals to v squared over 2. Then we can be able to make v the subject. And in that case, if you work this out, you are going to realize that you will have your speed of velocity being equal to 5.9 meters. 5.9 meters. State 2 other ways evaporation differ from boiling. This is a very common question that you can be asked. So something that you need to remember, evaporation, I think this is a crisis. This is evaporation, right? Evaporation occur on the surface while boiling occur in the entire liquid, in the entire section of the liquid. So that's the difference. Also, evaporation happens at any given temperature, while boiling will occur at a specific temperature. For instance, if we are talking about the temperature of the boiling point of water is 100, it means boiling will not take place until water has acquired a temperature of 100 degrees Celsius. But evaporation will occur at any given point. All right, so basically sometimes you may be asked, how does evaporation cause cooling? You may be asked such a question. So you need to be careful about it, because such a question can be asked, and you really need to know how to approach a question that is asked like that. So if you ask such a question, how evaporation enhance cooling, something that you need to remember is that evaporation occurs because energetic molecules escape from the surface of the liquid. So meaning that once energetic molecules escape from the surface of the liquid, then it means you are going to have only less energetic molecules remaining in that case. So it means that you have to, the amount of kinetic energy, or the amount of energy that remains behind, is less. Yeah. Another area that also you need to understand is the concept of converting temperature from degrees Celsius to Kelvin, and also from Kelvin to degree Celsius. All right, so I need to check this so that I can be able to ensure that you can be able to see what's displayed here. So if you are given temperature in degrees Celsius and you need to convert it to Kelvin, you will take that temperature in degrees Celsius plus 273 degrees. Remember, 273 is the absolute zero temperature. So meaning at that particular temperature, at negative 273, the object or the material, the molecules of the object has zero kinetic energy. But if you are given temperature in degrees Celsius or in Kelvin, and then you are expected to convert it back to degrees Celsius, if you are given in Kelvin and you are supposed to convert it to degrees Celsius, you need to subtract 273. So this question here, candidates who are given a temperature of negative 60, and they were asked to determine the temperature in Kelvin. So you will take negative 160, then you are going to subtract what? It will be negative 60 plus 273. Negative 60 plus 273. Yeah, so always remember this particular formula here. Temperature in Kelvin will be temperature in degrees Celsius plus 273, like that. State 2 method of thermal energy transfer that the vacuum prevents. This is convection, heat loss by convection, and also heat loss by conduction. Describe in terms of particles how gas exert pressure in the walls of the container. So in this question, what you need to remember is that the particles of the gas, or molecules of the gas, move randomly. They move in a random motion. As they move around, they collide the walls of the container, exerting a force. And the force exerted per unit area is pressure. So as the moment you are asked a question like this, remember that molecules move randomly, they collide with the walls of the container, and when they collide, they exert a force, and the force they exerted per unit area is pressure. You can also be asked, how does increase in temperature affect pressure? In such case, you are going to look at it from the perspective that increase in temperature increases the kinetic energy of the molecules. Then they are going to vibrate faster and they collide more with the walls of the container. Once they collide more, they are going to exert a greater force, hence increasing pressure. So increase in temperature increases pressure because kinetic energy of the molecules increases. But if the gas is cooled, you are going to say there will be less kinetic energy, and then there will be less collision per unit area, hence less force is exerted, hence pressure decreases. So questions can be asked in different ways, so you need to be in a position to answer a question or any question that comes. There was also a question to do with refraction. In this particular question of refraction, guys, all candidates were asked to explain why the ray, as it enters here, it does not undergo any refraction. It does not bend. Why is this ray here entering straight? Now, at that given point, candidates were supposed to remember that when a ray enters a material at 90 degrees or along the normal, at 90 degrees or along the normal, it means that the angle of incidence is 0, then the angle of refraction is going to be 0. Hence, the ray at this particular region here is going to enter undeviated without undergoing and bending. But when this ray reaches this particular point, remember it's moving from a dense medium, which is glass, to less dense medium, which is air. So when a ray of light is moving from a dense medium to a less dense medium, it means it's going to bend away from the normal. So it will speed up and it bends away from the normal as shown here. Because the ray is moving from a dense to less dense medium, then the ray speed will speed up. And when a ray speed up, it bends away from the normal, and then you are going to have your ray beautifully stated like that. So, and this section, candidates were supposed to complete the diagram by drawing how the ray is going to emerge out. So the first thing that I need to remind you is that you have to start by drawing the normal. Once you have drawn the normal, because this ray is moving from this point to the less dense medium, then it's going to bend away from the normal, and then you are going to have your diagram represented like that. And if you are new to Prof Learn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. Let's dive in and look at, explain why the ray does not change direction. We said this is because the ray enters the prism at 90 degrees, so the angle of incidence is 0. And if the angle of incidence is 0, then the angle of refraction will also be 0. Yeah, so that is it. Our next question was the relations between the critical angle and the refractive index. So the first thing that I need to mention here, you need to understand what do we mean? What do we mean? Guys, welcome. I can see, amazing. I can see Swabrina Said subscribed. That's great. Thank you so much for that subscription. And I believe you'll be joining me so that we can be able to going through different areas here. Guys, don't forget to subscribe, and also you'll be joining for more content also in A levels because I'll be doing much in your year 12 classes. So don't forget to subscribe and leave your comments. Thank you guys for joining. Okay, so we need to move further and look at this. What's a critical angle? If you are told to define the term critical angle, you are going to say critical angle is the angle of incidence in the dense medium when the angle of refraction is 90 degrees. So suppose you are having a glass block that is like this, and then we say there is a ray of light which is directed through the glass block. Through that, you see at this particular point there is no any refraction because this ray is entering glass at 90 degrees, so there will be no any refraction. So the angle of incidence is 90, angle of refraction will be 90. So that's why the ray is going to enter into the glass block like that and deviated. Then the moment we are going to have angle of refraction 90 degrees here, then the angle that we have down here is called the critical angle. So if you are told to define critical angle, you are going to say this is the angle of incidence when the angle of refraction is 90 degrees. So, but in this question, candidates were not supposed to do this. They were told to calculate the refractive index, yet the critical angle was provided. So candidates were supposed to remember this particular formula that we have here. Then from there, they could be able to use it at this particular point, because we are told the sign of 1/sin of the critical angle will be our refractive what? Refractive index. So if you do that, 1/sin 42 will give you 1.5, and that's what candidates were supposed to do at that given point. State two advantages of using optical fibers to transmit data. Number one, they have high rate of data transmission, meaning that the speed at which data is transmitted is quite high for optical fibers compared to normal wire all conductors. They can be able to transmit large amount of data because data is transmitted in form of light. So you can be able to transmit a lot of data within one optical fiber. Then also we can talk of there's no data loss, or there's minimal data loss in the process of transmission. Then we have question number 6. Question number 6 was basically talking about a sound wave, and the student was supposed to identify a compression and a rarefaction. And something that you were supposed to remember here is that compression is region of high pressure and rarefaction is region of low pressure. And we will identify our compression here and our rarefaction here, because you can see this is a graph. Actually, the graph that was drawn here is the graph of pressure against time. So meaning at this region here, pressure is highest. Pressure is very high. So meaning this is going to be a region of high pressure, and that is going to be a compression. Lowest pressure is this one. Lowest pressure. Then this is a region of low pressure, and that becomes now a rarefaction. Yeah, so you need to understand. This usually is sometimes indicated, drawn using lines. So you can be able to draw lines like that. You'll have lines that way. So region where lines are very close is called compression. This region where we have the lines very close, this is called what? Compression. Yeah, like one here. So this region here is compression, and this region we have quite relaxed, the lines are relaxed. This is called area rarefaction. Yeah, rarefaction. Okay. Explain why the graph cannot be used to determine wavelength. You can see the graph is having basically time on the x-axis. So there's no way this graph can be used to find wavelength, because usually wavelength is the distance between two crests. So we should have displacement in this particular region for us to use this particular graph to measure wavelength. So we can say this graph can only be used to measure period, because we are having time in this region. Yeah, can only be used to measure period, or can also be used to measure frequency, because frequency is 1/t. Yeah, so that's something that you need to remember. The graph does not show variation with displacement on x-axis, so that is the case. Now, sound becoming louder, it means amplitude has increased, and sound having a lower pitch, it means that frequency has decreased. So that one, I believe you will be in a position to remember if you are going to be asked such a question. I can see, guys, they are asking whether we are going to have A-level live streams. Yeah, I can consider if I have more members who are requesting. Yes, I can do live stream or a level math. Yeah. So if yeah, I can be able to do it if more members request. I can be able to do that. Yeah, I can do it. Sabrina, I can do it. Yeah, I can do that. All right, guys. I'll also have to look at the next question. And the next question was asking about speed of sound. The speed of here we are having the speed of sound. We are told the frequency is the frequency is 13 kilohertz, and the speed is 1,500 meters per second. Calculate the wavelength. For you to work out this question, we're going to use what we call the wave equation. You're going to use the wave equation here, and wave equation is usually V is equals to F lambda, whereby F is frequency, this lambda is wavelength. Then we can, if we want to find the wavelength, we're going to say is V over F. And in our case, you had to remember, the main thing that you were supposed to remember is that this is kilohertz. So you will multiply this by 1000. That was very important for you to remember in the process of working out this question. So that means that we are going to get our wavelength in 0.12 meters. That's quite key. That's quite critical in the process of working out this. Then candidates were supposed to mention the approximate speed of sound in the air, and you can see the value of speed of sound in the air is around 340, because we can say 330 all the way to 350 or 360 there. So, but whenever you are going to state your answer, you are not going to state a range, you are going to state the exact value. So just understand that it's 340, a value close to that. Speed in air is around 340. In a liquid or water is around 1,500. If you are going to be asked about a solid, is around 5,000. So those are some of the concepts that you really need to understand as far as this particular question is concerned. We have question number 7, whereby candidates were told to describe and explain how students can determine which piece is magnetized and magnetized only. Yeah. So meaning that if two pieces are magnetized, one is having a north pole and another one is having a north pole also, then there's one that is not magnetized. So which means that the student is going to, let me just have this one. This one is not magnetized, and I'm going to separate and have my pieces here. So we are having a piece that is magnetized and another piece that is not magnetized, and we have another piece that is magnetized here. So in the process, what a student will do will take one piece and bring it close to another piece. Check, is there attraction or repulsion? If there is attraction, it means the material can be a magnet, magnetized, or a magnetic material. Then once it has tested and there is the attraction, then the student need to flip the poles and then bring it close again and check, will that pole be attracted or repelled? So if both sides are attracted, it means this is a magnetized material. But if one pole is repelled, it indicates those are similar poles, and that is a magnetized material. So in this particular question, you are supposed to explain and say that the student need to bring each piece close to another piece and check whether there is attraction or there is repulsion. So if there is attraction in both ends, it means that is an magnetized material. But if one side is attracted and the other one is repelled, it means that is a magnetized material. So you are going to write that, and I believe you have understood exactly what you're going to do in order to do that. Now, I want us to move to the next part, and the next part is about step-down transformer. Need to mention that a transformer is a device. A transformer is a device that is used to increase or decrease voltage. A step-down transformer is a transformer that is used to decrease voltage, and you can be able to know is a step-down transformer by looking at the number of turns in the secondary coil. And you can see here we are having, this is called secondary coil, and this one here is called primary coil. So if you want to identify whether a transformer is step up, just look at the number of coils in the secondary and compare. Are they more? If there are more coils in the secondary, then it means this is a step up. If there are less coils in the secondary than the primary, is the step down transformer. You may be asked to explain how a transformer works. Now here, what you need to remember is that a transformer uses alternating current. When alternating current flows through the primary coil, it creates magnetic fields which are constantly changing size and direction. When those created magnetic fields cut through the primary coil, they are going to, an EMF is going to be induced in the secondary coil through electromagnetic induction. Get me right. When alternating current flows through the primary coil, it means that changing magnetic fields will be created around this primary coil. This changing magnetic field will cut through the secondary coil, and when they cut through the secondary coil, an EMF is going to be induced in the secondary coil through electromagnetic induction. So let's check what our student asked in this question here, in this year. Candidates were supposed to calculate the current. Candidates were supposed to calculate the current in the transformer input, that is in the primary section of the transformer. But candidates were supposed to understand that power in is equals to power out. Power in the primary coil is equals to power out in the secondary coil, and because the transformer was 100% efficient. So in that way, we are going to say that power in is going to be current in the primary coil times voltage in the primary coil should be equals to power output, because we are given the power output of the transformer is 45 watts, because here we are having what? Power out. So you can be able to say power in is calculated from current in the primary coil times voltage in the primary coil, but power out is calculated from current in the secondary coil times voltage in the secondary coil. But current times voltage is power, so no need to do current in the secondary coil times current in the secondary current. There's no need for us to do current in the secondary coil times voltage in the secondary coil, because that is basically power that is provided. So we shall now say the power out, which is 45, is equals to current in the primary coil times 240, because you are told the main supply voltage here was the main supply voltage was 240. That was the voltage in the primary coil, but we are working out the current in the primary coil. So you can see, you can take 240 divided by 45, and that's going to translate to nothing other than 0.19 amperes, and that is exactly what we're supposed to do. Students was told to draw a diagram to represent a step-down transformer, and what student was supposed to remember that a step-down transformer must have fewer turns in the primary coil, fewer turns in the primary coil, and more turns will be in there will be fewer turns in the secondary coil, but more turns will be in the primary coil. So fewer turns in this particular secondary coil, fewer turns in the secondary coil, more turns in the primary coil, and this becomes a step-down transformer. And you are supposed to label. This is we can see here whatever we are having here is a soft iron core. We have a soft iron core where those coils are going to be wound, and we have a primary coil, which is the input, and we also have the secondary coil, which is basically the output in that case. Candidates were supposed to add a voltmeter to indicate how the PD across the LDR, the light dependent resistor, can be measured, and that's exactly what candidates were supposed to do in this particular section of question number 8. Having question, but also when it becomes dark, resistance of this particular device here is going to increase. When it's dark, resistance of the LDR increases, and in that way there will be a larger potential difference across this because of high resistance. Yeah, so state the effect of change, this change when it became dark. So what does that do? It means that the resistance of the LDR is going to increase. And how is this going to affect the PD across the light emitting diode? It means that we are going to have a larger PD in this particular section here because of larger resistance. Yeah. So if you are new here, consider subscribing so that anytime we are going to do more tutorials, you'll be notified. So I believe you've gotten value. Let's move down to the next question. Then candidates were supposed to calculate the resistance of the lamp. These two lamps were connected in parallel, and the current that was flowing, we were told the current that is flowing is basically 0.5. Then you will use the formula V is equals to IR in order to calculate the total resistance of the circuit. And once you have calculated the total resistance of the circuit, you can be able to get it as 480. But since these two lamps are in parallel and they are identical, meaning they have, each of them is having resistance of R, then to get the total resistance, which is this, it will be 1 over R plus 1 over R raised to power -1. This is the formula when resistors are connected in parallel. So if you work it out, you are going to get it as R over 2, then times 4 times 2 both sides. The value of the resistance of each of the resistor will be 960. Yeah, so that is it. And candidates also were supposed to answer question to do with radioactivity. And in this case here, safety precautions when you are dealing with radioactive substances. The safety precautions will include wearing protective gears and also reducing exposure time when it comes to radioactive materials. You are not supposed to stay for long because those radiation will be absorbed into your body. So that, and also you can ensure that you operate those machines which have radiations using remote controls. Give 2 reasons why alpha emitters are not used as radioactive tracers. Remember, radioactive tracers are usually swallowed or are taken as food so that they are absorbed into a given part of the body. Then a detector is placed outside the body, so that they can be able to trace the movement inside your body. So a detector will be placed outside, so meaning radiations have to get out to be detected. But alpha particles they have low penetrating power, so meaning if they enter into the body, they cannot be able to penetrate through the skin. Remember, they can also be stopped even by paper. Yeah, so they are not used because they have low penetrating power, so they cannot penetrate out to be detected. You need to add that. Number two, they are highly ionizing, so the moment they enter into the body, they ionize blood, and that's going to be very, very dangerous to a human being. Use nuclear notation to write down the equation. We remember we were having sodium 24 and is having 11 protons, so 24 is the mass number and 11 is the atomic number, but it decays giving alpha particles. We are told here it decays giving alpha particles to form magnesium. But remember, beta, not alpha, sorry. It emits beta particles. So beta is 0, -1. So you can see now we can be able to balance the equation. So at the top here we have 5, -1. So if this is 11, we must have 12 here. So that 12 plus -1, it will give us 11. And since we are having 0 at the top here, we shall have 24 also for magnesium. Yeah, so that is it. And question number 10, candidates were supposed to, that is space physics, supposed to state a natural object that orbit around the sun. And in that case, candidates were to state comets, dwarf planets. Then the shape of orbit of planet is usually elliptical. And also, if a comet, a sun is always gravitated towards one end, this is the orbit of a comet. Yeah, so if you are asked that, it's moving very fast in this region, but I'm sorry, it's moving slow in this region, and moving very fast at this particular region. So you can also be asked orbit of a moon. Orbit of a moon is around a planet and is always circular. It's always circular. Yeah, so instead explain the energy transfer object from point A to B. From point A to B, this is actually a comet, right? This is it has kinetic energy, and as it moves, it decreases to gravitational potential energy. So which means that energy, the law of conservation, is considered here. Jupiter is this from the sun, this distance from the sun. The speed of light in the vacuum is that. We are supposed to calculate the time taken for the sun to reach Jupiter. So we know that speed is equals to distance over time. Then it means that time is equals to distance over speed. So in that case, candidates were supposed to say time is equals to the distance, which is 7.8 times 10 raised to power 11, divided by the speed, which is 3 times 10 raised to power 8. And if you put this in the calculator, you will get your answer as shown there. Name the galaxy that contains the sun. This is the Milky Way. State the theory of the universe that the universe light observed from distant galaxies is redshifted. This is Big Bang theory, and this supports because the universe is what is expanding. Yeah. So also state the CMBR is one of the evidence that indicates that the universe originated from Big Bang theory. And this is what we call cosmic microwave background radiations, which are always present in the environment. It means they were created shortly after Big Bang, and since the universe has expanded, it means that they have stretched to this particular region. So we can say they have I don't know why this is disturbing me. I need to say that I need to move this one here. So explain our state when they were produced shortly after Big Bang, and explain why the radiation is now microwave radiation. It means the universe has expanded and all those radiations have stretched and they have redshifted to the microwave radiation. So basically that marks the end of this particular tutorial. And if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to be uploading more, uploading more tutorials, you'll be notified. I'll see you in the next tutorial, and let me know if the video was actually helpful. See you in the next tutorial.